Uh, Hi guys. So this is a progress video for the EE533 project. So this is one of the last progress videos, and uh, so I'm going to show you uh, a progress that we've made over the last few weeks. Uh, this is the architecture of our project. Uh, we have packets coming in, and we have an hardware accelerator, uh, aka a Bloom filter, and whenever it detects a particular false positive, packets are sent to a processor, and the processor uh, drops it if it is a malicious packet. Uh, so we didn't have this functionality in the FIFO that drops the packet. Uh, so we made this particular progress in the week that we added this functionality of dropping a packet from a FIFO whenever a processor signals an ACK. So I'll be going to show you this. I'll give you a quick I'll take a quick detour of the current test bench that we wrote. Uh, this is one of the impressive test benches that we have ever wrote here. We've written a class and some virtual functions to generate packets in the simulation so that it's easier to test, and it can be extended to generate packets of any particular pattern or size. So I'll show you that test bench first. So we go to tests in our repository. We go to we go to utils. Okay, so we'll go to test bench utils. So these are the macros that we have written, which can be easily used across different test benches. It becomes easier when multiple people in our team are working on different component so that we can reuse these macros. So I'll go through some of these macros. Uh, so this is the channels macro, which uh, instantiates uh, upstream and downstream channels through which packets would be uh, flowing. So this is the class name NFUDP channel. Actually, it's an interface. So you see, this is similar to the NetFPGA ports of that are connected for upstream and downstream for packets. We have the data, we have the ready, and we have the write signals. So this is an interface. This macro particularly defines which channels, uh, and then we connect the different components just like the way we do in NetFPGA uh, modules. So I'll be showing you now this particular macro, which is declare packet source. This macro, we use it to instantiate a class that generates packets of a particular pattern. So this is a module called packet source, and you see we have different uh, tasks here. These are sort of the helper tasks, and if I go to this package called in system Verilog package called PKT, we see there are various class that extends the Blaze class. and it generates packets of a particular pattern. I'll also show you a test case that we've written for the processor that interacts with the FIFO, interacts with the packet in a FIFO, and after dropping it, it sends an ACK signal to the FIFO. So for the test bench, we pass this particular hex file, which is FIFO.eck.txt. Okay. This is the hex file that is used. That is a program, that is a hex code for a program that ACKs a FIFO after dropping a packet. So if you want to check out the deassembly of it, this would. So this is a deassembly of this that does an ACK, that the processor does an ACK of to the FIFO. And if we run it on a model cell, we also created a .do file for this that triggers this particular test case execution. File load macro file tests. We go to the FIFO ACK. Oh, hang on. So this is the wrong test one. So let's load a different macro file for now. So this is a macro file that generates a pattern for the packets that has 42s in it. And we will be printing this packets here. And we will also make the processor acknowledge the FIFO. So you see, these are the patterns that are provided in the source. And I'm sorry, these are the packets that arrived at the destination. So we don't print the packets that are at the source. Uh, we just print the packets that are there at the destination right now. I could show you the code for this. So if you look at TB top, you see we are using this macro called packet sync printing, and we connect it to a channel one, which I showed you before is also a variable. Uh, it is an array of interfaces of the NetFPGA channel ports that we made in this to simulate. So this makes our life very much easier by writing test benches which are uh, similar to what happens in NetFPGA, and it's easy for us to move forward. So this would be the, what do you call it, progress video for this week. Yeah, so the progress, yeah.